Hey everyone, and welcome to the PiCast. This is November 10th, 2020. I'm Avram Pilch, editor-in-chief of Tom's Hardware, joined as always by associate editor Les Pounder, Raspberry Pi expert Ash Puckett, and our special guest this week is Stan Nevedomsky from Turing Pi. Hi, Stan.
Hey guys, thanks for having me. I'm super excited to be here.
Thanks for coming. So, for those who don't know what what the Turing Pi company does, can you describe it for us?
Yeah, sure. So we are building cluster board. So this is a board where you can combine several Raspberry Pis and run them together. So, and the idea behind the Turing Pi, I have to say that the idea wasn't to get more performance out of the Raspberry Pi by combining them together. The idea was to create a cloud environment by creating a cluster. So, and yeah, a lot of people who are using Turing Pi nowadays, the reason why they getting Turing Pi is to have a local cloud environment. They have a lot of reasons to have the local cloud environment, but yeah, one of the reasons could be to save on cost. One of the reasons could be to put some cloud work locally, or to deploy applications before deploying to the cloud. So a lot of the reasons. But yeah, the idea behind the Turing Pi is to give this local piece of cloud.
That makes sense. So, how long has Turing Pi 1 been out?
So we started the project like 1.5 years ago, and we launched the first batch in February this year. Yeah, the hardware is hard, so it takes a lot of time to build something like this. But we are super excited about upcoming Raspberry Pi 4 compute module, and we are working on the next version of the Turing Pi.
So, there's going to be, we know on your website, turingpi.com, there's going to be a Turing Pi 2, and it's going to support the compute module 4. What else can you tell us about it? It looks like it's a different design because it's the one is an open air design. It looks like from the picture on your site, the Turing Pi 2 is going to be a closed case. Is that correct?
Yeah, that's correct. But the case will be optional. So the we are going to build the cluster board in the first place, but based on the feedback we got during the first version, a lot of people they're asking about case, and a lot of folks out there, they want to put this board into the case and use it somewhere, I don't know, for at home or for business purposes. So yeah, we decided to take it further and build a case, but this will be optional. So yeah, the new version, the Turing Pi 2, is going to have less nodes. In the first version, we have 7 nodes. We're going to have less nodes. The reason why we're going to have less nodes, the performance of Raspberry Pi 4 compute modules is pretty impressive. So we believe that even with the 4 nodes, you will get impressive power of the cluster. And the next thing, what we are trying to build, we are trying to build the minimum blocks that you can use while building your edge computing infrastructure. And by having 4 nodes, you still have a cluster. You can benefit from everything that cluster gives you. And also with the 4 nodes, you can fit in a pretty good price point.
So what are some of the things that you anticipate people doing with the Turing Pi 2? Do you see it being sort of edge computing AI, servers? What?
Yeah, so the whole idea behind Turing Pi is to build a device for edge computing. And why we think cluster architecture is important. It's not a secret that almost every software nowadays hosted in cloud. And when you host in cloud, you put your applications or services in containers and you spread these services or applications between different nodes, between different clusters. And you have you could have such tool like Kubernetes to orchestrate all these nodes, all these containers, to balance everything. So, and our idea was to build, so if every software is in the cloud nowadays, and if you want to take some of these services or applications and put it in the edge on the local infrastructure, why the software architecture should be different? It should be, it should coexist. So that's why we are thinking that clusters is the right solution for edge computing.
That makes sense. So how would you see someone implementing this? Implementing this in the business or at home? Are they going to do something like set up any kind of redundancy, so if one of the modules fails, or are they just going to have all the nodes working on the same task to increase speed? Is it more about failover or more about increased performance?
I believe it could be both. So yeah, of course, when you host your application or your services in the cluster and you use tool like Kubernetes, and you can host different applications or services on different nodes. And if one service requires more load at some point, the Kubernetes can balance the node and can scale this service to other nodes. And if one node, let's say, fails, other nodes could take the work of this node and heal the failed node. So this could be about stable work as well, and but it's also about how you deliver applications. The very interesting use case, the Chick-fil-A, how they use clusters in their restaurants, and the one of the reasons why they use the clusters in their restaurants, because again, they build their applications for cloud, and they don't need to rebuild the same applications for the local infrastructure. They can deliver. They build once, but they can deliver to the cloud and to the local infrastructure at the same time. So, and this is a huge benefit. So this is not only how you make all the applications work, but also how you can deliver them, how you can scale them when needed, and things like that.
So this is a fascinating question that Oren asks. By the way, I want to, as always, invite anyone who's watching live to ask us questions on the chat. Oren asks, "Hi, will a Pi clustering allow for split-screen gameplays?" What? I don't know what a split-screen gameplay is, but does anybody? But do you, Stan? Do you, Les?
Isn't that like Halo or something, where they just divide it? Like you can have multiplayer on one screen?
That's what I think it is, yeah.
Yeah.
Is that what you meant? Is that what you meant, Oren? Sort of having two systems, a split screen, like one half of the screen is one player and one half is the other?
Like Mario Kart or something.
Yes. Well, I love that when my son and I are playing console games. That's for sure.
Yeah, that's what he's talking about.
Like 4 players in Halo. Well, I don't know. Could it? I don't know if any game has been architected to do that on Raspberry.
Yeah. So, but basically, Turing Pi is a board that combines several computers and interconnects them with Ethernet. So, and basically, how you can think about Turing Pi, if you can do some things on several computers interconnected with Ethernet, you can do this on a Turing Pi as well.
But then, I guess the interesting question would be, how would you get them to output to one screen as two separate windows? Half-Life Engine already supported on the Pi 4.
That's true. Les was playing on it.
Fascinating.
Yep.
I would love to see someone do this. Of course, the cheater's way to do it, which I even can't do because I don't have a monitor that supports it, is if you had a monitor that was did picture by picture or something like that, and then you just outputted a different. I mean, that's not really a cluster, but you could output different Raspberry Pi to half of the screen. But that's obviously not what we're trying to accomplish. But I would love to see somebody try to do that. Try to do a multiplayer gaming, multi-screen gaming with it. Of course, I guess it also kind of begs the question: if you've got multiple Raspberry Pis, could you not get multiple screens? I guess it depends where your Pis are probably cheaper than the screens. So. OBS Studio. Oh, somebody says OBS Studio does such compositing. This is true. You could composite multiple feeds from OBS with OBS Studio. I don't know what kind of lag you would be getting, but a fascinating concept, and I would love to see somebody try it when Turing Pi 2 comes out, or even with clustering right now, which you can do. Without the compute module 4, you could do Raspberry Pi 4 cluster just with regular Raspberry Pis by linking them with Ethernet and installing the correct software. So that would be really fun. If anybody can set that up, I want them to come on the show and show it. So that is really cool. So what else can you tell us about Turing Pi 2? Do we know when it's going to come out yet, or about how much it'll cost?
So we are still working on, we have a great community, and we got a lot of very interesting feedback from the community, and we are still working and still validating some of the ideas that we would love to see in the Turing Pi 2. But I must say that Turing Pi 2 will be a whole different monster, I would say. So the new compute modules, they gives us SATA ports and PCIe ports, and this open whole a lot of new opportunities, like connecting drives to the cluster. And this, in this case, you get a complete cluster unit with a lot of storage. You can connect different expansion boards like 5G modem or LoRaWAN card, and the next version will be something where you connect drives and you can extend the possibilities of the cluster with extension ports, and we are super excited about this.
Will you be able to share one drive across all the nodes, or will you need a different drive for each node?
Yeah, again, same thing. Several computers interconnected with Ethernet. So far, we are planning that only one node will be exposed to drives, but you can share the drive through the Ethernet.
That makes sense. So you only need to have one boot drive across all 4 nodes.
Exactly.
That makes sense. So a lot of power there, a lot of performance for computing at the edge. So speaking of compute module 4, Les has been spending a lot of time with compute module 4 and has managed to push it to the limit. Tell us, how fast have you been able to get compute module 4 to go now?
Okay, well, yes, I've spent quite a number of days with the compute module 4. So here is one in my hand right now. Let's just get the cameras focusing a bit. And it's upside down. Rookie error. So these are tiny little things. They're basically a Raspberry Pi 4 in a smaller board. They need a carrier board and I/O boards to work with them. So I've got one in front of me right now. And apologies to no overhead cam this week. It's decided to die at the last moment. I've got this connected up to a Pimoroni fan shim to keep it cool, and I've been doing some overclocking experiments. The stock clock is 1.5 gigahertz, which is as a normal Pi 4. I've managed to take the compute module 4 up to 2,275 megahertz, so 2.275 gig, and it's working stably. It runs quite warm. If I just quickly go into my spreadsheet to check the temperatures, it runs at about 70 Celsius at load, so using a sysbench test. That's 15C under the maximum cutoff temperature. And it runs surprisingly well. I did have it running at 2.3 gig. Unfortunately, it's horribly unstable. If you don't touch it or do anything with the compute module and just have it there as a piece of technology and art, it will run comfortably. But the second you put it under any load, such as doing an update with apps or stressberry test or opening a YouTube page, it will instantly just crash the machine. Unfortunate, but we tried, and it was great fun. And I really want to push it as fast as I can because it's a great piece of kit.
Wow, wait, so we have to ask Amir, who keeps coming on as a listener, to come on our show sometime, because Amir says he was able to get his RPI for up to 2.33 gigahertz.
Silicon lottery.
Oh, and somebody else apparently able up to 2.47. Whoa! Now, were those compute modules or were those regular Pi 4s? I wonder, because last week when we had Evan Upton on, he said that there's a new stepping, meaning it could actually go faster on a compute module 4 and on the Raspberry Pi 400 than you get out of a regular Raspberry Pi 4 board. So,
if Amir can share his config txt file, so I can have a look at what config they've done, I can possibly recreate it on a compute module.
Yes, well, we would love to try to do that. We're all about trying to get it to a higher speed. I mean, I wonder how much of it is silicon lottery, meaning you just get lucky. Although Les did try it with 2 different units.
Yep.
So maybe it's luck of the draw, so to speak. Stan, what is the fastest you've ever gotten a Raspberry Pi 4 to go?
I wouldn't say we did a lot of tests with it.
Yes. Yeah, I mean, obviously, at a certain point, there's diminishing returns. Like, how much faster is it actually going to be going from 2.1 to 2.3? But we're Tom's Hardware, so we're all about doing stuff because you can, not necessarily because you should. Certainly 1.5, the base clock. If you boost it up to 2 or 2.1 or 2.2, then you're getting a significant bump of more than 25%. So that is meaningful for something that one might do. When you get down to like 10 megahertz, will you notice? No, but that's not the point. I mean, obviously, what I'm curious about is Les still wasn't at the throttling speed of 80. This throttle point of 85 degrees. So what do you have to? What do you really have to do? Even making it cooler isn't necessarily going to allow it to go up. But I'm really curious to see that. So speaking of extraordinary things people have done with their Raspberry Pis this month, Ash has which we didn't get to talk about last week because we had Eben Upton on, and that was, obviously important that we just talked to him the whole time. But she has our projects of the month to talk about. So what are some of the coolest things people did on their pies in October?
All right, this is for November. We did October last month.
Right. Rather, they did it in October, and these are the projects for November because we're in November now. But anyway,
Right.
yes, projects of this month.
So just in case anyone's watching who isn't too familiar with what we do, every week, all throughout the week at Tom's Hardware, we will post projects that people are working on in the community. And these are things that are either submitted to us directly, which if you're watching and have something you're working on, send it to us. We want to see it. But we look around online. We look at the Pi community. We see what you guys are up to. And we have a list of 10 projects out of everything we've featured this month that we think you guys need to take another look at. And I've got just 3 of them I want to highlight right now on the podcast for everybody. So I'm going to switch my feed over to my computer screen. And what you guys are looking at is a Bitcoin node. It was created by Tyler Jones at howchu.com, which is another website I write for. And this is entirely on a Raspberry Pi. We've got a storage device hooked up here, and it's functioning as a node on the Bitcoin blockchain. So the entire chain is connected to this node. And I wanted to bring up this project because we have somebody else who works with us, Carolyn Dunn, and she has created a Raspberry Pi Bitcoin mining project. And I think Avram had some of the numbers. How long would it take to actually make money off of it?
So this is interesting for those who might want to say Bitcoin mine with your Raspberry Pi. We have an article on how to not Bitcoin, I should say crypto mine. Bitcoin Bitcoin is not the coin you want for this. So Caroline did it with Monero, which is another currency, and she was able to get it to mine some Monero in a few hours, but in order to withdraw the actual money, you need 0.05 Monero, which is equal to $5.81 right now. So considering that the speed at which it was operating, Caroline figured out it would take 3,762 years to mine enough Monero, the $5.81 of Monero, to actually do a withdrawal. But perhaps if you had a Turing Pi cluster, it would only take you like 800 years. Does that sound like, Stan, like something that could be sped up with cluster computing?
Absolutely. Why not?
Yes. So it would still take you a while, but maybe less than a millennium to do it.
One thing to note, you can always combine several clusters together.
That's
right.
true.
So, I mean, if you did enough, I mean, we know that there are people out there or businesses out there or organizations out there that have clusters that are, hundreds or thousands of pies. So they might be able to make $5 in a day. Granted, the amount of electricity that they would have to use to generate that $5. Let's assume that it's somebody else's electric bill, but your own $5. Then it might be worth it. Maybe you have an entire solar plant or something like that to get your $5. Your $5 mined.
That's how the Raspberry Pi community works, though, isn't it? It's like you want to make something because you can, not because it's efficient. Sometimes it's efficient and makes sense, but if you can do it on a Pi, why not?
Exactly. So what other cool things were people working on this month?
Another one I wanted to show off was this really wicked, awesome Raspberry Pi Sky camera. It uses the HQ camera inside, and if you see in this demo picture, there's like a streak across the night sky, and what the camera is set up to do is snap a picture of the stars once every so many seconds. You can set your own intervals, and it overlays each picture into a single file. So at the end, where all the stars were, you end up with like streaks, and it's beautiful because you can see just how the stars move at night in just one glance, and it's really, really cool. I haven't seen a sky camera that's just I don't know, compile some like a final product that's so cool. So that was one I had to show off. And there's one more while I've got you guys. This guy crammed a Raspberry Pi inside of his model rocket so that he could measure the telemetry data in real time. And you can see the little interface here of some of the readout. It's got velocity information, temperature, pressure, pitch, yaw, roll. You can see what the entire rocket is doing throughout the entire course of the launch. And I just thought that was cool. I used to work in aerospace, so maybe I'm biased to rockets, but this is a really cool use of a Raspberry Pi.
So could you fit a cluster in a rocket?
That's the question.
I think everything is possible if you have a goal.
It would have to be a slightly larger rocket than that, but you'd probably get better telemetry.
We have to try.
Yeah, the question, do you need to do this?
Well, it's electronics everywhere, right? What can you do? What can you do that's different? I'll show again, and I'm really close to having this ready for GitHub, but I showed this a couple weeks ago when I was in an earlier stage. My son and I have been working on something that's a little bit because you can type of project ourselves. This is a let me actually fire it up. This is a so this right here is a platformer game that runs on an LED matrix. This matrix is actually technically a Pimoroni Unicorn HD hat, and what it does, it doesn't have the music playing right now, but it has actual character that you are, and you jump around. They're bad guys, and you try to make sure you don't touch them, but you can stomp on them and kill them. And then there's coins. And we did the whole thing with Pygame. So if I was good at doing this one-handed, I would show you that we've actually added levels to this. So when you touch the red flag, you go to another level that looks like it's underground. And some of the work that we've done recently is on actually getting new sound effects that aren't copyrighted from somebody, so that we can actually put this on the site or on GitHub so other people can play with it. But
That's cool.
The concept is, why would you play on one of these? Well, I've seen other folks. I saw someone on Reddit this week who'd created Pong on an LED matrix. So that is
Come full circle.
That is really cool. Being able to do things on different types of displays that you haven't been able to use before, or you wouldn't normally expect to game on. You wouldn't normally expect to do something on. Is where some of the fun is. So we have a question. Jared asks, how does a Raspberry Pi compare to the chips used on the space shuttle? Aren't those still something like 8086 processors?
Way
Well, I
better.
don't know the answer to that. Do you? Do any of you?
Way better.
Wait.
ARM CPUs, a lot faster, a lot more efficient. Way better than 8086. I mean, I was using them when I was in high school. That's how old I am. But there are at least two Raspberry Pis in space on the International Space Station. Viz and Via, I think they're called. The
Astro Pis.
Yep.
Yes, but those are Pi 1s, right? Is that correct?
Yeah, they are. Yes, I think they're looking to put newer Pis up there. I'm not sure if they've done it actually. I haven't looked at it for a while.
That's so neat.
Well, they're up there. They're not allowed to be plugged into the ISS's power system. They have to be powered from a ThinkPad.
Really?
And I know this for certain. Yes, they cannot be plugged into the power system, even though they've been fully flight certified to go up there. They can only be powered from a ThinkPad. I think it's a B+ is a UCL. Yeah, safety in case it goes power spike or an issue.
You really don't want to mess anything up while you're in space, so.
Yeah.
It'd be bad. Yeah.
I would actually love for that's a to-do for us. We need to kind of follow up and find out what the status of those is, because I know periodically they have, I think the European Space Agency has contests for kids where they can have their code run on one of those Astro Pis, but I don't know if they're still doing it on a regular basis or not.
They did the last 2 years. They might have one.
So
the competition's still going. I'm just not sure what kit they've got up there now. But I can certainly ask, because David Honus is a friend of mine, and he works for the European Space Agency and was the lead for Ashpro Pi projects at Raspberry Pi Foundation. So he's going to get a tweet very soon. Hi, Dave.
See, I think the question is, can they actually, put the compute module 4 up there in a cluster, right, in outer space? Because they need more processing power than that. But I think, to Jared's question, I don't know a lot about space exploration, but it seems that anytime you compare current day computing to what was used on the space shuttle or on the Apollo missions, the current day is better, but we still can't go. So obviously, proving that computing power is not the most important part of getting to outer space, since our computing power has gotten better, but we haven't got back to the moon again. So. But that's another story for another day. So I want to thank our special guest Stan Nevedomsky from Turing Pi for coming on, and always thanks to all of you who listen and watch in real time or after the fact. You can always find the Picast live at 2:30 p.m. Eastern, 7:30 p.m. British time on Tuesdays, and after the fact available on YouTube, Facebook, and as audio wherever you get your podcasts. Thanks, everyone, and we'll see you next week.
Thank you, guys.
Bye.